My name is John. This is me riding an inflatable horse. I'm from Tasmania, where I run a company called Secret Lab with Paris, who's hiding in the corner at the back of the room there. We're mostly known for writing a whole bunch of these things, a whole bunch of books, mostly for O'Reilly Media. What? Oh no, it's not changing. Great, okay. So, yes, as I was saying, this is me. Was wondering why there was no reaction before. And like I said, I make these things along with Paris. We do a whole bunch of books. Most of them are about game design and game development, which is an area that I'm really, really into. And also, I write non-stop. In fact, this book came out very, very recently indeed. So, like I was saying, we make a lot of games. Well, that is, we used to until the best game of all time came out, which is this. Anyway. There's a whole bunch of really awesome stuff coming out in iOS 9, and I wanted to just take you through a couple of the cool things if you haven't had a chance to look at it yourself. So in particular, I want to talk about mostly ReplayKit and GameplayKit. I'll touch very brackets, not as brand new and shiny as the rest of the stuff. So let's talk about ReplayKit. ReplayKit, have you guys heard of ReplayKit before? No? A few nodding. So the idea behind ReplayKit is it's taking advantage of this big thing that everyone's doing. A lot of games these days are really into streaming games. Now, what you can do is you can take advantage of the built-in screen recording system that iOS 8, well, everything from iOS, I think it started in 7 and 8 and 9 have got built in for what I'm doing right here with my computer. I'm streaming my screen content to somewhere else. So what ReplayKit does is it lets you record the contents of your screen to a video file, which can then be sent out to Twitter, to Facebook, to anywhere, any destination that UI Activity Controller supports. Now, Apple makes a big deal about privacy, as you might have noticed. So this is especially the case with the contents of the user's screen. A lot of potentially very private personal information happens on the screen, which means that when you're using ReplayKit, a whole bunch of restrictions are in effect. The screen recording never records any of the system UI, so no notifications come in that are recorded. The user still sees them, it just isn't part of the recording. The keyboard is never shown, so you can't infer their password from looking at the little characters moving around. The user is prompted every time. The application, this is really important, never sees the final video. You actually don't get a video to work with. All that happens is you get a view controller, and inside that view controller, the user chooses what to do, and that will be either to save the video or to share it out to some third-party service. And finally, parental controls can lock the whole thing down. So if you're a parent and you don't want your kids sharing what they're doing with their friends, then you can just turn the whole thing off as an individual granular control. So ReplayKit works with the same recording system as powers TV Out and AirPlay. So what that means is if the user is using either of these features, then ReplayKit can't be used. So the same hardware that actually does the hardware compression of the screen's contents into H.264. So I want to show you a quick little demo of the whole thing in action. I'll be tempting the demo gods a lot tonight. Okay. So, the way that ReplayKit works is you deal with this object called RP Screen Recorder. I'm just going to open that up a bit so we have a bit more room. There we go, RP Screen Recorder. Oh no, haha, I forgot. All right. There, okay. So I'm actually looking at like a delayed version of the screen from over here, so this is going to be interesting. Okay, let's try and move that a little bit closer, just so we can all see the contents. There we go. Okay, so you can make use of this thing called RP Screen Recorder.Shared Recorder. So you work with the singleton, and all that you do with it is you tell it to begin recording and to stop recording. Now, when you stop recording, what you get is, I'll scroll a little bit further to where we're actually doing our work. So, You basically say, I want to start recording. I care about the microphone, yes or no. Even if you say, I want the microphone, the user is still prompted to say, do you want to let this app record the microphone as well? So you can say, I want the microphone, and the user can say, no. So when you call start recording, you get back a callback saying, okay, it either started or it failed, and then it'll just start recording silently in the background. The CPU impact on the whole thing is really minimal because it's all being done on hardware, which means a lot of power savings. Now let's take a look at what happens when you stop recording. So there it is. And again, it's a very minimal API. You'll notice that all we do is we say stop recording and you provide a callback. And this gives you back an optional preview view controller and an error in case something goes wrong. If you have a view controller, then the way that you use it is you present it modally. And inside that view controller, the user is responsible for scrubbing back and forth, taking a look at what they recorded, trimming it, and also from there they can choose to either save it, send it to somewhere else, or just discard the whole thing. So you never ever see what they recorded. So it's very cool. Unfortunately, the screen recording system does not work on the simulator, which means you have to do it on the device. And I don't trust this whole setup very well to try and AirPlay from this device as well. So anyway. So that is screen recording. Hopefully yes, cool. So now, screen recording, as you might imagine, is not really designed for create some kind of tutorial system. We do that using UIKit. It is completely, talk about GameplayKit. GameplayKit is completely independent of your technology systems. It is a whole bunch of gameplay logic, really, really high-level stuff, really abstract stuff that a lot of video games tend to re-implement over and over. Every single game that has AI in it tends to re-implement the same stuff over and over again in the exact same way. So what Apple have done is standardized. So it's good for video games. So one of the elements that's included in really, really interestingly, this is one of the very first things Apple talks about in their documentation. Oh, no, I've just lost the connection. I will jump back on that. There we go. All right. Nice. Let's jump back into this. Great. Okay, so randomness. So randomness is really, really, really important in almost every single game, apart from maybe chess. Pretty much every single game has some kind of element of randomness in it. But what we care about is not actual randomness. We don't really care whether our random number system is cryptographically sound. Like, we don't need to be using arc4 random, even though we all do anyway. So what we really care about when it comes to randomness in games is things like deterministic randomness. We want to be able to get the same sequence of random numbers every time. Like, they should be random from the perspective of we don't know what comes next, but when we run the test again, we should get the exact same we don't know what comes next. It makes sense. We also want controlled randomness. What that means is we want to be able to do things like given a range of numbers from 1 to 10, we want to have more 5s than 1s and 10s. We want to be able to say, like, certain things have a weighting to them. And we do this all the time in board game design, where, have you ever played a board game where you roll 2 die and you end up with a certain value? The reason why they gave you 2 D6s rather than a single D10 is because if you roll 2 D6s, you'll tend to get clusterings of values around 7. And that's on purpose. And finally, we want fair feeling randomness. A lot of people complain about defeating this monster and then the same monster comes up again. Like, that's not fun feeling. Like, it's totally mathematically correct, but no one actually wants correct, they want fun. So GameplayKit's randomness features have all kinds of stuff that's built in to try and address this. So I want to show you what that looks like. And tempt the demo gods again. Okay. Jump into that, open up this thing, I'll drag this across. Okay, Cool. Okay, so I've got a really, really simple RPG that I totally made in a single afternoon. And it's really simple. In fact, it's so simple it actually doesn't have anything besides the fighting system. So we have a couple of constants that we set. We say we're going to let the player possibly fight up to 20 monsters, and they have 100 hit points. And what I want is I want to have randomness in which monsters appear, whether or not we're going to fight anything at all, and also how much damage is done. We want to be rolling dice. And I want to have different kinds of randomness for each of those three different types of things. So let's take a look at what we do. Okay, so I've got a list here of the different types of monsters that I can be fighting. Now, what I want to have is not the same monster twice. It's really boring to fight the alien and then see the same monster come up again, or even like really soon after that. You want to be fighting a shuffled list. Next up, I also want to have a random distribution where it's more likely that I roll things closer to the center of this random distribution. So given a dice with a 10-sided, well, rather a 10-sided dice, I'd rather have things roll in a 5 rather than a 1 or a 10. So that's called a normal distribution. Oh, actually, wait, I made an error there. That should be for the damage dice. The fighting dice, I just want a 3 in 10 chance. So that's what, you'll actually notice that we actually have a method here called .d20. That actually returns a random generator that has a value from 1 to 20. So there's also a D6 as well. So if you come from D&D and other role-playing board games, these terminologies should be fairly familiar. And next up, we've got a random source here that, as the comment mentions, it tries to avoid clustering. So the GK shuffled distribution is a random source that tries to not repeat itself. It tries to avoid drawing the same thing twice. So if you keep drawing, it will repeat eventually when it runs out of new stuff. But it'll only start drawing new stuff when other stuff has been played already. So that's a shuffle distribution. It's really handy. So the logic here is really straightforward. If you want to get a random number from any random source, you just say next int or next value or things like that. So let's see how it goes. I'm going to hit the play button. Here. Actually, no, it's already run at the bottom here. So zooming doesn't work on AirPlay. That's fine. But the idea of this is that it repeatedly runs code saying, do we fight? If it's greater than 30% chance, then ignore. Otherwise, we do a whole bunch of fighting where we keep rolling dice and end up either defeating it or not. So randomness, it's good stuff. Okay. So video games have started to get more sophisticated in recent times, and this is kind of indicative of the kind of trend. People want more in-depth content in what they're experiencing. And this demands a more sophisticated approach to how we develop those games. One of those methods is a state machine before. Raise your hand. About half of you. So the idea behind a state machine is it addresses the problem of keeping track of state being a really, really tricky thing to deal with. So a state machine can help. I want to imagine a situation where we have 3 states in our game. We can be in the main menu. We can be in the game itself ended. From the main menu straight to game over. That makes no sense. But we want to be able to return to the main menu from anywhere. So really what we want is where it starts to get a little bit complicated. So here's how a state machine can help. You can define each of these 3 states and then define the possibility for you to transition from one state to the next. You can say go to game over, but you should not be able to go back unless something. So you can use GameplayKit for that as well. And it's available in this page. So the way that GameplayKit models all of this stuff is you create instances, rather subclasses, of a class called GK state. And GK state can actually just be empty. As you can see here, there's actually nothing in these. All they are is just named subclasses of the GK state abstract superclass. Then we define a state machine by saying GK state machine and pass in an array of instances of these states. And we kick things off by saying state machine, enter this state, enter the main menu state. You can query the current state by saying, what is the current state? And so we'll run this here and it should evaluate to true. And I can actually do that here. Hopefully, it does. True, yay. You can also add additional logic to your states by saying, here, let's extend main menu state and override the isValidNextState method. And what this does is it returns a true or false value indicating whether or not it's allowed to proceed to another named state. So we'll say the main menu state is only allowed to proceed to the in-game state, the game state here. It's not allowed to go straight to the game over state. So it can only allow to go to the game state. So when I call state machine the game over state, it says false, not allowed to. But if we go through game state and then to game over state, that's true. Now the idea of a state machine and the real power of it is you can run code that happens when a transition occurs. So you can do things like when we click on a certain button, we tell the state machine go from main menu to in-game. And at that point, your state machine can go, I'm transitioning, clean up the scene, play a different sound effect, set up everything ready for the next scene. So you can see this in, we've got a couple of method overrides here, did enter with previous state and will exit with next state. So if you're arriving from another state, you can run code here, and if you're going to another state, you can run code there. You can see in the console, it's a bit small there, but you can see that code running, saying we've entered the main menu, we're moving to another one, now we're back in the main menu. The next thing that game architectural problem that if anyone ever made mods fun. So here's how we used to do it. We used to use an inheritance-based approach to our game design, where let's say we have a really base class called object, and we've got two different subclasses. Right, let's add some sophistication to this. We're going to go, all right, we'll add a shooting class. So maybe the monster class should shoot, and maybe the player class should shoot as well. So let's rearrange it and do everything and do some best practices. And then we went, oh, we forgot to add damage taking, and I don't want to have that in part of the classes. That should be broken out, and we don't want to be modular. So we'll define a new class called damage taking, but okay, so we'll make that, it has to be a subclass of object, I guess, and so the monster now needs to inherit from that as well, but that doesn't work because objectives can Swift and support multiple inheritance, and also what about the player? Can they take damage as well? And yeah, it just gets nasty. So here's a better solution. You define a thing called entities are containers for components. So you can add components like shooting, damage taking, graphical representation of it, an AI for it if it's a monster. Based approach up the individual chunks of behavior and logic into one little piece that can be applied to multiple things. Every single they'll need to render a 3D model of some kind. It's not something that's inherent to being a monster. That's just a thing in the game. So the entity component model is a much more flexible approach to it. Another thing that's kind of cool, so adding intelligence to your video game characters is important. The idea behind seek a certain, I want or I want to avoid obstacles, and that's using pathfinding. That's also available in GameplayKit, and I won't have time to talk about. So the last thing that I have to show you is a bit of a demo of agents as they're used inside GameplayKit. And hopefully, okay. So here we have an object. This has all been done in SpriteKit, and I have not written anything besides, as you'll see in a second, I'm telling this to wander around and to avoid the obstacles. So there's no other target happening here. It's just moving around and dealing with the fact that there's a wall in front of it everywhere it goes. Let's take a look at how that actually works. Okay. Here it is. So I've got a function here, not a class, but a function that returns a GK entity. GK entities represent that container for components. And there's a whole bunch of components that I want to add to this object. There's a sprite renderer, there's also an AI component. So I've defined a class called sprite component elsewhere in this file, and all that does is it's a wrapper for a SK sprite node. Now, the reason why it's a wrapper is because that wrapper is a subclass of GK component, which is the object that can be attached to other entities. Next up, we add the agent. So we create a GK agent 2D, which is a special agent that can work inside a two-dimensional environment, because GK agent is actually defined to be a 3D agent, so it can pathfind in 3D space as well. So once we have that, because you'll notice that we say let agent equals GK agent 2D, then we attach it directly to the entity. So agents are components already. There's no wrapping needed to be applied here. So we set up the agent, we give it a couple of parameters, some mass, some maximum thresholds and such. Then we give it a goal. The first goal is to wander. Second is the goal to avoid obstacles. Once you have your goals, you can only have one if you want to. You create a behavior by defining a number of goals, and you indicate which ones are more important by defining the weights. So you can say it's more important to avoid obstacles than it is to wander, if you wanted to. So that's pretty much it. That's all you need to know for agents and for the entity component system. It's a really straightforward, simple system. Oops. All right, so yeah, that's pretty much it from me.